Good morning to everyone. So today I am going to start quality assurance and quality control in highway projects, roads, and some portion of bridges also. First thing, before going for the presentation, first we should know there are two types of codal provision. One for low volume road, other for national highway. We are covering left side traffic more than 450 commercial vehicles per day. If you see any traffic on national highway, the code SP word will not come except manuals. Like IRC 37, no SP, IRC 15, IRC 112, 37 for flexible. And in the case of national highway, we have separate code for construction, separate code for design. Whereas in the case of low volume road, when traffic is less than 450 commercial vehicle per day per lane, it is the single code for construction and maintenance both. Like IRCSP 72 flexible payment, IRC 62, uh, and this code is applicable for ODR and MDR also. Like these are low volume road. When low volume road connect with the city, it become ODR road. Then in the district road, then district road. So these are the code. When district road connect with the state, then ODR, other district road. So then we come to state highway, the lane which join with the national highway. They are governed by the state. The highway which connect two state, that is national highway. Mostly single lane is a low volume road, or you can say intermediate road also, 5.5 meter width. They comes under rural road, low volume road, and more than two lane or more than two lane comes under national highway. So these are the codal provision. In case of national highway, we go for MORTA specification, Orange Book, till now 2013, and for low volume road, MORD specification. Our today's topic mainly for quality control. Earlier we have three codes: IRCSP 11, IRCSP 47, IRCSP 57. Those code have been deleted. In place of that code, IRCSP 112 has come. It covers full highway. I am covering IRCSP 112, the main section. And regarding particular, because SP means for special work, like low volume road, special only for low volume. In the case of IRC code, these are not only for national highway. These are being adopted by urban road also. They are adopted some by state highway also. So that is why we have not put SP word. But if you see the manual, IRC SP, it is only for two laning. 73, 84 4 laning, 87 6 laning, 99 now 2023 expressway. To decide where we should go for rigid payment, first we should go for flexible. Suppose in the schedule B also, suppose the consultant somewhere has given something wrong. So it is our duty to check that also. Mostly all underpasses, if you see, it is better if you go for rigid payment. The reason is the life of structure is 100 years. Life of bituminous road is mostly 6 or 7 years. So every 6 year, if you put some overlay, then your vertical clearance will reduce. On the deck or underpass, if you are having a flexible payment, after 6 years, it is better if you scarify in that over the deck also and underpass. And in all over the world, where we go for rigid payment, where we go in mostly any road along the river, like Yamuna Expressway, we have a rigid payment. All petrol pump, all apron of the airport, rigid payment. End of the runway, rigid payment. All toll plaza, rigid payment. Where vehicle stop and start, where oil spillage chances are there, we go for rigid payment. In national highway, in the urban section also, wherever urban area, we go for a paver block. Wherever moisture is there, heavy moisture, heavy rainfall is there, we should go for a rigid payment. Now, if you see IRC 75, every slide I have given the reference also. IRC 75 says heavy black cotton soil area where chances of settlements are there, allowable settlement is 3,300 mm, 30 centimeter to the design life. If it is a high embankment, means more than 6 meter or 6 meter. Correct? So if settlement per year is up to 25 per annum, then you can go for flexible. If settlement is more than 25 per annum, we have to go for a rigid payment. It is clear. We should go for a bitumen, not rigid. In case of embankment on soft clay soil, like Madhya Pradesh, or you can say Karnataka, Maharashtra, West Bengal also, where clay, heavy clay is there, it is difficult to avoid. Rigid payment may not be suitable. Appropriate type of flexible payment may be provided. Like in Kavarda also. If you see Chhattisgarh, Madhya Pradesh, mostly there are even Bundelkhand also. Pure silt also it is a harmful somewhere. That also I will cover. This is regarding. Now, if you see the cross section of flexible payment, there are 3-4 things which are required for quality control. As per IRCSP 84, 4 laning manual, 6 laning in all the 3 manual, what is written here? The bottom of the subgrade should be 601 meter above the highest flood level. The top level of the road or a bridge is decided by the highest flood level. In the case of bridges, vertical clearance between the bottom of the deck and the HFL. If discharge is 3000 cubic meter per second, then 1.5 meter vertical clearance. In case of roads, highway, the bottom of the subgrade should be 1 meter above highest flood level. It is written there also IRCSP 84. Second thing, top of the subgrade shall be 0.5 or 0.6 meter above the OGL also, original ground level or natural ground level, you can say. Top of the subgrade shall be, if not possible, other parameters. If you go from bottom to top, the strength should uniformly increase 2 times or 3 times. Uniformly, if suppose the magnet CBR is 3, then subgrade CBR will be 3 into 3, 9. Then 9 into 3, 27. Then 27 into 3, 81. 81 into 3, 243. If you multiply CBR into 10, get E value. The E value between layer is 2400 roughly. So there should be uniform increase in the strength. You cannot put weaker material over the stronger material. Like we can't put WMM over the bituminous layer. There should be, the second thing is, we must have steps in each layer. The reason of providing step is load on the structure or a bridge, it comes at 45-degree angle. So minimum extra step equal to the height of the top. We go for 1:3. The advantage of this is compaction of the edges become easier if you are having a step. Water will not come back due to potential energy, it will go up. The subgrade is to be, the camber is to be given in the subgrade top. In the case of bridges, camber is given in the pedestal top. Whereas in the case of roads, camber is given in the ground or in the top of the subgrade. Minimum thickness for subgrade, for national highway, 500 mm, and for low volume road, 300 mm. Then GSB minimum thickness 150, minimum thickness for WMM or WBM in low volume road, 150 only. Black top, it depends on that. It can be minimum 40 mm usually we are having. This is the cross section. Permeability should decrease 3 times. Aggregate size should decrease 3 times. Like in the GSB, you are having a soling, 9 inches, then 3 inches. Clay and silt also should decrease 3 times. So these are just thumb rule I am telling you. Now where it is written? It is written in IRCSP 84. What is written here? The bottom of the subgrade shall be 1 meter above the HFL. No section of the road, top of the subgrade shall be 0.6 meter above the ground level. If not possible, then what MORTH on page 68 says, it is written here also. If not possible, then your subgrade and top of the embankment must be have same 97% compaction factor, density 1.75. In that case, you may avoid this. Both should be fully compacted. Means your effective CBR will also be 10. Both will be 10 in that case. In that way, you can avoid this bottom of the subgrade portion. You can refer this also. Now coming to the quality control, earlier we have 3 codes. Is it visible? Na? Hello? Screen is visible.
Yes, sir.
Hello?
Yes, sir. Yes, sir.
If you see bottom 3 code, it is a copy IRCSP 112. Today I am covering this. Earlier we have IRCSP 11 for roads, IRCSP 57, Q1, Q2, Q4 types, and IRCSP 4. These code have been deleted. In place of that, we have comes under IRCSP 112. Why we need quality first? whose money we are using. If you are making a national highway, who is paying for that? The paying is user. So in the highway, first line for quality control is user must enjoy safe riding quality. If an user is not happy, means whatever we are doing quality control, we are not doing justice to our uh, project. Second thing, the vehicle operating cost should also be as minimum as possible. Suppose for 1 kilometer, whatever you are having, so it should go a maximum length. Resource we must use efficiently. Not only that, one contractor is using full good soil, the other is not having. One is using full water, he is not getting single water for the villagers also. The resources, there should be value engineering also. Resources efficiently, lower bid price, faster construction. These are the 5 basic reason we have to go for a quality for the highway. And this is, and every slide where it is written, you can find on the top also, please. Somewhere there may be some mistake. Whatever I am showing you, it is taking from the codal program. Coming to the, there are 4 5 terms regarding quality. One is quality control, other is quality assurance, third is quality audit, fourth is quality management. What are these? I will just check. The first person who is doing quality control may be a XCN, maybe A, maybe junior engineer, maybe overseer also, maybe unskilled, skilled person also. Then checking of this person, whether he is doing as per specification, technical part, it is the duty of quality assurance person. Like assistant engineer, he will check the duty of the junior engineer, whether he is doing right way or wrong way. Then executive engineer come, he may be a material engineer, he may be a project manager. Then next is the project manager, maybe superintendent engineer level. Everyone, the first one will check, suppose the contractor, he will check 100%. The consultant will check, say, 5 to 10%. The client will check 1%. This is written in the code. I will just come step by step. First, what is quality control? What is the meaning of quality control? Operational technique of controlling the quality. Important requirement for construction for ensuring quality durable. Now, there are 2 terms. One is ensure, second is assure. What is the difference? One is assure, other is ensure. Ensure means personally you are checking also. Not you are depending on someone. He is saying, yes, sir, I did 25 stroke. I have done 3 layer, 4 layer slump. That is not. You have to see personally also. Maybe 1%. That is, you have to ensure quality and durability. Assure means quality control as per specification. Quality plan means if you write all these process on a document, it is quality plan. If you are writing quality control parameter, then quality assurance plan. If you are writing something else, it will. So this is a quality plan definition I have shown you at the bottom. Now, assure means a person, something to make him or her confident about the acceptance. Yes, sir, it is acceptable. Ensure means something personally you are doing. There is one more term, ensure. Ensure means you have to give the time bound manner also, like within this time I will cover. If I will complete, you can give me a reward. If I do something wrong, you can give me a penalty. On 4th December, there is one circular also, you can say. That also I will show you. What is quality assurance? Witness. Make certain of the quality, whether quality control is done in a right way or wrong. Inform positively. Certain, we suppose you checked and you are not informing to the senior, that is also wrong. Assure somebody of the truth. Give reassurance, commitment as per acceptance criteria. These things comes under quality assurance. And quality assurance plan already I have shown you. It is written full detail. You can refer class this page 8. This is the new circular which have come recently on 4th December. I think NHI policy, just few days back, I was going through it. What is written here? If you are getting excellent good quality road, means roughness index 1800, you will be awarded. If your roughness index is 2500, it is unacceptable. No, you will be called, the contractor will be called as a non-performer. Consultant will also have to be justify why he is not doing this thing. So he has to visit the site also. He has to advise him, not he should be a master on it, like this is wrong, this is wrong. How it is to be corrected, that is the duty of the consultant also. Now, in this code, duties of each and every persons are given. Qualification of each and every persons are given. Staff is every. So if we fulfill this, I think we can assure our quality will be good. For example, contractor. If the project cost is less than 300 crore, he should have a one material engineer, two quality control engineer, four technician. If project is more than three, same, only lab technician should be six, 50% more staff. Quality control, consultant. If we come to the consultant, if project is less than 3, he must have a one material engineer, one quality control engineer, two lab technician at site. He should check with his work. Suppose he is checking, he is not getting full knowledge of how to, it is the duty of the consultant to train him. This is the way you have to take in a 3, you have to put the road vertical like that. If project is more than 300 crore, the consultant must have authority engineer, must have one material engineer, two quality control engineer, and four technician. Second thing, coming to the client, what are the duties of the, how much staff client should have at site? If you are having a maximum number of DPR to be assigned, two DPR, no other responsibility, then NHI or the ministry must have assistant executive engineer, deputy manager, 2 number, executive engineer, manager, deputy general manager, 4 number, with no other responsibility, or two with other responsibility. Civil engineer, general manager, four with other responsibility. So these are the how much staff we should have for making the DPR also, PIU also. So how much staff we should have. If you see the PIU, maximum number of the projects, how much project, you cannot give 5 project to one person. Assistant executive engineer must be given one project, no other responsibility. Executive engineer should be given two project, no other, or one project with other responsibility. So these are the things, if we follow whatever given in the coder provision, में जो हमारा संविधान है, it would be better, we can get a good. Now, what are the duties of contractor? He should have a operational skill. He should have a good training. Like today, they are getting structure. IMT, inspection, measuring, testing equipment. He should be aware about that. When to do calibration, how to do calibration, what is the methodology. He should put on a QAP on non-conformity, how to apply the non-conformity corrections. The consultant must give non-conformity if it is not doing as per the coder provision. He can reject also. He have to see the safety provision, the most important part also. Otherwise, nowadays you have to pay something for that also. What are the duties of the client? What is the duty of the consultant? In short, I have written here, client must check 1% of the total work. It is written IRC SP 112, page 28. 34. These are the pages where it is written. And for the consultant, he should check minimum 5 to 10%. Metrics for testing supervision is test. List of the equipment he should make. Control the laboratory he should have. Consultant, he should have control on all these things. His duty is to control and inform the client NHA. So this is happening here. This is happening here. As per TOR, terms of reference, he should check, or as per CA, or as per schedule A, B, C, D, whatever we are having. Now, material engineer, main part is the material engineer from the contractor. What he should do? He should regularly supervise the activity or take his assistant, quality control engineer, quality control assistant engineer. He has to visit site almost daily, once a time. Preparation of quality assurance plan, the material engineer will prepare. Then project manager for preparation of the working methodology. Setting of the laboratory, material engineer will do. Calibration of the equipment, material engineer will do as per the IRC SP 112, section 3, page 12. If you come to the material engineer, other main duties of material engineer is how to do Joe mix formula for the bituminous or a concrete. He should know what are the coder provision. Now, in place of MS2, IRC code has come, IRC 135 on the bituminous mix design. In the revised Morse book, we have deleted MS2. Now, IRC SP 135 is there. For concrete mix design, we should use 10262 for bridges and IRC 44 for rigid pavement. Monitor and coordinate the quality control at site. These are the duty of the material engineer. Ensure, not assure, ensure test as per IS code. He has to see once whether they are doing as per IS code or IRC code. Maintain test record. It is the duty of the material engineer. Forward to the consultant. Corrective action on the non-con. If suppose consultant give you some non-conformity, Suppose you call him that I am going to start the pre-stressing tomorrow, and you without his presence you started, then he will put a known conflict to you. He can check the core or something else. Internal audit also he has to do from first from his, then third party. Third party means he will not be the person from the client. He will not be the person from the consultant. He will not be the person from the contractor. IIT or CRRI or somebody else, they will do the quality audit. If suppose there is a big problem in some schedule or in some item or in some clarification, then project management means the higher level person, client level or the highest authority of the contractor, say authority engineer, independent engineer, they will come into the picture. That is quality management. Then liaising with supplier. Suppose you are getting a bearing expansion joint or some road marking paint, then you have to do liaising also. Material engineer will do. He will take the staff from the consultant PIU also and then check all the things. Just few example I am giving. Suppose you are checking the aggregate. So what are the code revision? What is 383? Whether we have to follow 383 or Morth book or IRC 15 or structural. So what are the different parameters which are given in the code provision? We have to refer that. Mainly water absorption not more than 2%, loss engine not more than 50%, silt not more than 5 or 8%, depending upon the combine of that. So these are the few things which we should check site. For grading also, in bridges, most of the specification they say go as per IS 383. However, in the case of concrete road, slightly different, or flexible payment also, slightly different specifications are given as compared to IS 383. So please refer the respective, see the for bridges. If suppose there is an individual aggregate is failing in 10 mm, 20 mm something, so combined grading is most important. Here one thing more to learn. When any aggregate is defined, it is defined by nominal size, not maximum size. What is the difference between maximum size and what is the difference nominal size? Nominal size is 90 to 100% or 95 to 100%. Second row is the nominal size. The first row, suppose 20 mm aggregate nominal size. Maximum size is 40. Nominal is 95 to 100. If you come to 40 nominal size, the maximum is 80. Nominal is 40. And please remember the the aggregate sand portion must be around 50% of the coarse aggregate everywhere. If sand is very good quality, you can take 50 or 55 also. If sand is say medium quality or poor quality, you can take 30% sand and then 70% coarse aggregate. This value you can change also during big DI. So these are the grading regarding. If you see the other thing, what is MORT? Now there are different code, MORTH, IRC, 2 laning, 4 laning. First priority is MORTS specification. Second priority is 2 laning, 4 laning. Third priority is IRC. And above all, first is a contract agreement. If something is not given in the contract agreement, then go for more. Then next manual, then next IRC code. For testing, only IS code. For execution work, we have to follow IRC code, MORTS specification. Just few quickly I will show you. Suppose fine aggregate, passing 4.75 mm, 90%. Fineness modulus, not less than 2. Like zone 6, zone 4 sand is having fineness less than 2. It should not be greater than 3.5 also. So 1008 section, fine aggregate. Please refer only the red box which I am showing you, only one line from each slide. Try to get the knowledge. Coarse aggregate. Flakiness index, not more than 35%. Correct? IS 383 clearly written. Everywhere IS 383 is written. So we have to go for pre-stress concrete everywhere. You have to follow IS 383 aggregate in the case of bridges, and in the case of concrete road also, wherever written 383, follow that also. Now, coming to structure, the most important part regarding the maximum size of the aggregate or nominal size of it must be 1/4 of the thickness of the member. Whereas in the case of flexible payment, 2.5 times, 1 upon 2.5 times the minimum thickness of the member. Ductile detailing के लिए Please refer IS 13920. All these details are given in IS 13920. 10 mm less than the minimum lateral clear distance. If you are having a two steel bar reinforcement, the aggregate size 10 mm less between the distance of the two reinforcement bar. 10 mm less than the cover. These are the three important things to select maximum size of aggregate. It is written maximum nominal size. There is one more thing. One is nominal size, other is maximum nominal size. Suppose in the concrete road kit says you can use 31.5, 26.5, this. Then maximum is out of all the three. Whatever is the maximum nominal size, you have to go for that. Next, come to the cement part. First, what is cement? If you try to understand, 70% clay, 70% limestone, 30% clay we take, calcine at 1400, we get tricalcium silicate. When you grind, it will immediately set within 2 minutes. To control the setting time, we add plaster of Paris of gypsum to control the setting time. Correct? This is just brief I am saying. This is called pure ordinary Portland cement. No fly ash, no slag. This is called ordinary Portland OPC cement. Correct? Now, if we come to next slide, if you see just small chemical reaction, what is the difference between 33 grade, 43 grade, 53 grade? It is the chemical composition, not the fineness. It is the chemical composition, not the fineness. Please remember, tricalcium silicate sets at 3 days. So we do cement testing at 3 days. Dicalcium silicate sets at 7 days. We do cement testing at 7 days. And please remember, setting of cement is equal to preparation of the curd. If you see the picture above, we are having a cement paste 0 minute, fully spherical. After 1 hour, like curd, crystal starts forming. If you going on shaking, you will not get good crystal. It is clearly written when you are doing a concrete work, there should not be any vibration just after placement. Homework, you should not walk on it if it is setting. You will not get good crystal. What is the chemical reaction? If you try to understand, then you can understand why we use fly ash, why we use slag, why we use silica fume. Only with this reaction you can understand. When tricalcium silicate reacts with water, they form crystal of tobermorite gel. Crystals are formed, which give you this strength. This is chemical resistant. It will not react with chloride and sulfate also. 25% lime which is generated, this reacts with chloride and sulfate. What is happening when you add fly ash or slag or silica fume? They are acidic, silicic acid. They react with this lime and form same compound, CSHL. So your permeability is reduced. It is written in the Morth also. In coastal area, whenever chloride sulfates are more than 2%, you should not use OPC cement. You have to use Portland Pozzolana cement, Portland, particularly in the case of pile foundation. Mostly slag cement is being used. Correct, sir? This is regarding the hydration. If you see next slide, coming to fly ash. Fly ash, there are three fly ash in our national highway which we are using. One fly ash we use commonly replacement of cement, 3812 part 1. Second fly ash as an admixture, replacement of sand, part 2. Third fly ash is IRCSP 58, replacement of soil. Fly ash, we must active silica 20%. Second fly ash, no. The sand which you are replacing with fly ash, we should not have any reactive silica. We should not have any finer material. Here size is bigger. Here size is finer. Part 1. Part 2 size is bigger. Here we should, if you take 10 gram fly ash, put 50 ml hydrochloric acid, 20% must dissolve. If you are taking bottom ash, add mixture. If you take 10 gram fly ash, 50 ml hydrochloric acid, it should not dissolve. There should not be reactive silica, spherical silica in the fly ash. That is used IS 3812 part 2. If you combine these two, they comes under the category of fly ash for geotechnical property. Here, the density is the main parameter, 0.9 to 1.6. If we are using density, then soil specification will not be applicable like 1.75. We have separate specification for the soil. Sand must have 7 to 90%. Gravel, you can have at least 10% gravel size should be there. Coefficient of uniformity is given. So all the things, moisture, how much. So please refer this also. And a minimum specificity 1.9, maximum specificity 2.2. Specificity below 1.9, you cannot use as a soil replacement also. So these are the few things. You select one or two at least. If it is failing, so at least we should have a quality control engineer should check this also. Hai na, sir? Coming to the plasticizer. There are two plasticizer. One is plasticizer, there is super plasticizer. Plasticizer means they make the concrete in a plastic condition. Whatever shape you want, you can make it. IS 9103 for testing. Most important test is the marsh cone test. If you add whatever the quantity of admixture is required, less, it is also harmful. If you are adding more, it is also harmful. Both are harmful. You have to use the optimum quantity of plasticizer, liquid plasticizer. And they are liquid admixture. They add in the mix. One is solid admixture. This I have already. They are mineral. These are mineral admixture. They come from mine, from earth, silica fume, slag. These are mineral admixture. This is chemical admixture, liquid. What we do, we take 1 kg cement, 35% water, make the paste, take the same marsh cone tube which you use in a bentonite slurry also, put 1 liter from the top, find out the time coming. Use different percentage, 0.4, 0.8, 1%, 2%, 3%, then make the chart. As per IS 9103, when your time of coming the material comes constant, that is the minimum water required. Minimum, like 0.8 is the minimum plasticizer by weight of cement you require. If your cement is 400 kg, and so 0.8 means 3.2 liter admixture, 3.2 kg admixture we can add by weight of cement. So now there are 4 types of plasticizer. First generation lignosulfate, second generation melamine, third, last one which commonly we are using, 90% people, we are using PCE based, polycarboxylic ether based plasticizer. What they do, they create temporary negative charge on the cement particle. Just like when you wash your clothes, when you put liquid cloth soap, they make negative charge on the dust. When you wash the cloth, that dust goes into the water, your cloth becomes. Similarly here. When you put in plasticizer, temporary negative charge occurs. They repel cement particle and micro level airs are generated. They increase workability. Minimum 20% of water you should reduce if you are using plasticizer to get same slump. Reduced, that result is not good. As a thumb rule, if you take 1 drop of plasticizer in your finger, rub it. After 2 minutes, your finger must stick with each other. Simple test for the plasticizer. Take 1 drop of plasticizer, rub it, and after 2 minutes, your finger similarly. If you take a 1 gram cement, rub it. It should look like a greasy powder. It should like a grease. Simple test for plasticizer, pH value 7 to 8. What simply just learn only 2 tests. That is also good for checking and having the quality. Minimum 2 tests is must for each and every person, I think, as per my pH value. It should not be acidic. It should must reduce water 20% to get same slump. Third, test how much percentage you should add. So these are the thing I have shown you. The super plasticizer reduce 40% water. And the first 3 are called plasticizer. The fourth one is called super plasticizer. Suppose you further enhance the properties, you further want to reduce this, then you have to add one more thing in it. Mostly the manufacturer, they are adding 0.1% VMA, viscosity modifying agent. By adding 0.1%, that the charge becomes stabilized. The 40 micron thick will remain 40 micron till 3 hours or 4 hours. By like super plasticizer in self-quantity concrete, VM is a must. Because there we need slump for a longer period. Coming to water, there are technical tests that also is are given 1010 water section, but simple 2 tests. Past 6Q, 3 with distillery water, 3 with sample water, 90% strength you should get. 90% strength we must get. Second thing, pH value, not more than 6, not less than 6, or 6 to 8. Or nowadays you can have a digital pH meter. Aqua Sol, now tubes are available, different companies. Renboxy, you can use that. Within 5 minutes, you can do all the tests. You can use the kit and first you calibrate once. Without calibration, please don't use. They may give wrong result also. If you are doing a pre-stress concrete, then you have to RO plant, you have to put at site. For pre-stressing concrete, if slide chloride sulfates are there, you have to put RO plant. RO plant shall be used at site. And for chemical plasticizer, IS 9103. Both have specificity approximately 1. Coming to the slump. Earlier you were finding slump in 4 layer. Now it has come to 3 layer. It is IS 1199 part 2 2018. Now IS code for concrete fresh and hardened have been revised after 60 years. Earlier code was 1959. Now 2018, 2020 codes have come. So few things regarding concrete I will show you. First thing regarding slump. Suppose one junior person is finding the slump. In place of 25 stroke, he is doing 30 stroke. It means quality control is being done, but quality assurance is not being done. The person who is doing, he is right. But the person who is quality assuring assistant engineer, he is wrong. He has to justify why he is doing 28 stroke. In the code, it is written 25 stroke. He should put in a vertical manner. So all these things comes under the quality assurance. Quality control person, whatever you say, by go inside, find slump, 3 layer, yes sir. So he will do. What is slump? When concrete slump down comes down, the distance how much comes down, that is the slump. So this is, if you want, I can show you small video if it is working, if it is audible or so. Sir, ये आ रहा क्या आवाज?
Method can
Is
be
it audible,
employed
sir?
either in the laboratory
Yes,
or
sir.
at the site.
आवाज आ रही है. Suppose I will just show you
Apparatus
Yes,
required
few.
for slump test.
Top dia 100,
The mold for the test specimen is in the form of the frustum of a
3
cone
layer.
having the bottom diameter
Here we
of
were having
20
4 layer. 20
centimeters,
centimeter,
top diameter
1,
10
height 300.
centimeters, and height of the
If you
cone
do
is
in 3
30
layer, 100,
centimeters.
100, 100. Earlier 75,
A metal
75, that
plate
is
of
wrong.
thickness 1.6 millimeters is used as a base. A tamping rod of 16 millimeters diameter and 0.6 meters long is used. Let us now see the step-by-step procedure for concrete slump test. The internal surface of the mold should be thoroughly cleaned and freed from moisture. The mold is filled in 4 layers, each
Now 3 layer.
approximately
This is the
1/4
earlier
of the
video.
height of the mold. Each layer should be tampered with 25 strokes
25
with
stroke. This is the
tamping
most
rod,
important as far
such
quality
that the
control.
strokes are distributed over the cross-section. After the top layer is filled, the concrete is struck off level. The mold should be removed from the concrete by slowly raising in the vertical direction. Now, you will notice concrete tends to subside. This subsidence is referred as slump of concrete. This slump value is then measured by the difference of the height of the mold and that of the highest point of the specimen.
How it should
This
come? Please
difference
see,
in
there are
height
3
is
pictures.
taken as slump of concrete.
2 are wrong, 1 is correct.
The pattern of a slump is displayed on the
Only the
screen.
first one is correct. If your come slump, it is a wrong, unsatisfactory. It is given in the code also, sir. You can see this picture is given in the code. If your slump is like this, it is a true slump. If anything fails by shear in concrete technology, it is a, if your girder fail by shear, you fail by shear, it is a rejected concrete as per new IS code. This distance is called the slump. Correct, sir? Now, how much slump we should have? Please refer MORTH table 1707. So detail I will not cover, already given the presentation and numbers are also given. For pre-stress concrete 75 to 25, for pile foundation 150 to 200, for structure, inclined structure, slope, approach slab 25 slump. So these are the slumps which are given. Now, earlier we were facing a problem when you are casting tube, whether you use damping bar, damping rod, needle vibrator. So now this confusion has been avoided by the new code. IS 1199 on fresh concrete. IS 516 is testing of hardened concrete. Both are 2020 or 18 now. Sir. So IS 1199 part 5 says, first they give you the specification. If you are using a needle vibrator, out RPM 7,200. If you are using a table vibrator, RPM 2,400. If you are using damping bar, 25 square. If you are using damping rod, 16 dia. Now, where to be used where? Not only in the cube casting, at site also. Suppose 11 part, what it says? Less than 15 vibrating table or needle vibrator. You cannot use damping bar, damping rod if slump is less than 50, like for concrete road. If you are casting cube, you should check with it. If you suppose more 100, then only damping rod. In the field also, you are not putting that vibrating needle vibrator. If only damping bar, damping rod you should put. If medium slump is there, 50 to 100, you can use anything, either vibrator or table vibrator, internal vibrator, you can use anything. And vibrating table or internal vibrator, you can use if slump is 15, or damping bar or damping rod also you can use. This is given there also. Now, coming to the cement part, if you are working in a coastal area, then please use composite cement. 1 part cement, 1 part fly ash, 1 part slag. IS 16415. Any cement bag, blue marking means slag cement, red marking means fly ash cement, black marking means pure OPC cement. Please refer the color and the week number also. Time is also given. Any cement more than 3 months old is rejected. Now, there are now two more cement. Earlier we are having 33 grade cement, 43 grade cement and 53 grade cement, yellow portion. They were having same fineness, same setting time. Difference was only chemical composition. Now we are having two more cement for pre-stress concrete, 43S, 53S. S means for railway cement, sleeper cement. Sleepers are pre-stress cement. And this 43 grade cement have strength higher than 53 grade. If you see the 7-day strength, 37.5, here 7-day strength 37. Now there is a maximum limit also. Earlier we have 3 codes, IS 269, IS 8112, IS 269. IS 12269. Now we have a single code, only IS 269. Now every OPC cement has 5% fly ash or slag or lime powder as a performance improver, marking black in color. Please remember, any strength more than 15 megapascal is rejected today. Why? If your 43 grade cement is giving a strength 59, that cement is rejected today. The reason, it will create more variation in the concrete. Maximum variation allowed is plus minus 15%. So any strength more than 15 megapascal is rejected. Please remember this point also. Now my question is, why we have 33 grade cement? Why not 32? We are using a 40 grade concrete for deck slab, and 40 grade concrete for pier, and 40 grade concrete for pedestal also. In concrete door also, why our cement is 43? Anybody can tell, sir? Anybody from the audience can tell why our cement is 43? Why not 42? Why not 50? Any person? What is the reason? Am I audible, sir? Am I audible?
Yes, sir, you are audible. Sir.
Hello? The answer is next slide. As per Morse specification, I1717, if you are doing a concreting, average of the 4 sample must be greater than FCK plus 3. You know, sir? If you suppose I am making a concrete, my cement is not 43 grade, how can I make a concrete? The strength of concrete is related to the strength of the cement also. If you are doing M50 grade concrete, you cannot use 43 grade cement, you cannot use 33 grade cement, you have to use 53 grade cement. The reason of having 53 grade cement is, if I am having a 53 grade cement, my strength will be chances of getting more than 53 grade. Even target is more than that also. Hai na? Second thing, in this new grade, these cements are, I think, rupees 100 rupee more costlier than normal for. The reason is they are having a almost double fineness, double setting time. Like initial setting time of 43 is 30 minutes and 600 minutes. Whereas slags, this pre-stress cement is 60 and 600, and fineness is around 370 meters square per kg. So because of this, please refer this also. This is regarding now in case of core. If you are having a core, when to cut the core? What this code says? Only in case of doubt. Second line, evaluation of compressive strength by taking core may also be done in case of doubt regarding the grade of the core. How to check that doubt? You are having a rebound hammer. I don't know whether it is visible or not. Hai na? If you see here, sir, whether it is visible, sir, I am showing you this rebound hammer, or everyone might be having this also. With the rebound hammer, you can see that we can find out the roughly the strength. By checking rebound hammer, suppose you find it is giving very less value, 20 or so, then we can ask cut a core from here. Suppose he asks you come and cite at so much and he did the work, then it is your duty to check the core also, or NDT test or other test also. Correct? So this is the reason from where. So mostly I am covering only the codal provision. Same thing. No, these are the now. This is the Morth book because 2013 it was there. So they have written the old number. Ordinary Portland Smith 269, 43. Now in the revised Morth book, I think which is just in a final stage. Maybe after a few months you may get that also. Portland slag cement, rapid hardening cement. So these are the cement. The most important part is maximum cement, like setting of curd and setting of cement. Both are the same. If you are preparing a curd, you take the tone milk, not the fat milk. Too much here also. If cement is more than 450, you will not get good crystal. You can use fly ash or slag or anything. Maximum cement per cubic meter is 450 kg per cubic meter. Means in 2400 kg total material, your cement should not be more than 17 or 18%. Correct? Now, what are the tests as per MORTH we required for the bridges? Only two tests on cement. If you have brought some truck has come, find out the compressive strength, find out the setting time. MORTH section 1000. Any cement more than 3 months old, rejected. So please follow the instruction as per given there. Now, in case of same thing happen in the case of concrete road also, FCK +3. है ना? Other thing, you can say flago strength also FCK plus 0.3, 4.5. So 4.8 is the acceptable flago strength also. How much sample you have to take? This is the most important for quality control. If up to 15 cubic meter, you have to take 2 sample, means 6 specimen. 6 cube in case of structure, normally we don't take a beam, we take only a cube, 150 mm by 150 mm. Correct? So correct, sir. So now, what is the time of mixing? 2 minutes. As per 1708.3.1, if you are having a normal, we should take 2 minute mixing time, not less than. IS 4926 you should follow. You cannot do volume batching. Only within 30 minutes, mixer must have out of this more than 30 minutes shall be thoroughly cleaned and ejected. Transporting also within up to the final setting time, up to the initial setting time, you have to transport the material. Now coming to the mid-design, full, I think difficult to cover. Only 3 slides I will show you how to do mid-design of the concrete. In case of bridges, in case of road, small difference is there of the target strength. Otherwise, 99% mid-design procedure is same for bridges and for concrete road. In case of bridges, because life is 100 years, code says you go for this also, go for 1.65 into standard deviation. In case of bridges, we take standard deviation 7 or 8 megapascal. In case of road, we take 5 megapascal. This is the only difference. Like if I am designing a 40 grade concrete, correct? My target is 52. If I am doing a CC road, 40 plus 1.65 into standard deviation 5, it is coming 48. That's all. This is the only difference. How to get target. With this, what changes occur in the median? If target is 52, bridges, in the case of road, target is 48. What will happen? This is the chart which is given in IS 10262. What is Abraham's law? Anybody can tell. What is Abraham's law? Anybody, sir? From consultant side. What is Abraham's law? Picture is given in the answer is given in the picture. If water cement ratio is increased, strength is decreased. So water cement ratio is inversely proportional to compressive strength. Higher the water cement ratio, if you see the higher the water cement ratio, 0.65, lower the strength. Lower the water cement ratio, higher the strength. Correct? So water cement ratio shall not be less than 0.25. Please remember, because minimum water required for chemical reaction is 25. This law is applicable when water cement ratio is more than 0.25 and maximum 0.65. So there are three curves. There are three curves. Curve 1, 33 grade cement. Curve 3, 53 grade cement. Suppose my target is 52. If my target is 52, my water cement ratio is 0.34. For bridges, my water is 0.34. If I am doing a concrete road work, it will be 0.36. Now if you see for the concrete road, I will use 43 grade cement. Suppose my target is 0.36. What is only? Now I have prepared one software also. This also I will share with NHI. You can refer that also. You can do any median with this software. Suppose I am opening this here software. If it is visible also. Is it visible, sir? Software, Excel.
Yes,
Only
sir.
in the green color you have to put the values. The green color put 2 or 3 values. The median is before you. Suppose I am putting M40 here. Standard deviation, suppose 5. 48 is the target. Suppose I am doing a concrete road median. The water cement ratio was 0.36. Enter. I have put all the water absorption plasticizer content here. Now you see the median has come. Please note down this value. The median is 1:1.5:2.8. Now suppose I want for bridges. So in bridges only you will change the water cement ratio. Suppose in place of 0.36, I am putting 0.34. Just put the outside cursor and enter. If you are entering this, now the median you will get for bridge 1:1.4:2.67. Water content, everything you will get. If you want fly ash, then fly ash code is also given here also. And you can go for rigid payment, you can go for DLC, you can make M100 also, you can make for roller compacted concrete. All softwares are here. So please refer this, and all the details are also given here. Suppose you are designing mix, charts are also given. For bridges, use this, correct? And these are the figure also I have given. So you need not to go anywhere, or you don't need any code also. Okay. So these charts are also given. IRC 44 standard deviations are also given. You can refer this also. In short, I have shown you this. So please refer that also. So this is for rigid payment, M40 grade concrete. So 1:1.4 is to, sorry, for 6.7. Now, if suppose due to some emergencies, nowadays, suppose you are doing a pedestal work, you are doing an expansion joint, repairing expansion joint, because life of expansion joint is 25 years. Suppose heavy traffic is going on, then you have to do a accelerated curing. You need median. Within 2 days, you can do the median. You have to follow two code, one IRC code, other IS code. IRC 85 code is on accelerated curing or IS 9013. And just wash the cube. Next day, boil in water for 3.5 hours. Whatever strength you are getting, it is X. If you put X here, if you put X value here, then you will get the 28 day strength next day. So within 2 days, you can find out the 28 day strength as per the codal provision. As per there are IRC code also, IS code also. Both you can follow. Now this code has come in IS 516 also now. So we can go for this. Now coming to the other points with regard to the quality control, I will quickly go. Just please refer the mode section. If it is already there, how to find chloride content, what is the chloride content limit in the total. Suppose you are working in Rajasthan or a Gujarat. There in the aggregate, mostly they is black or reddish in color. They have chloride. So you reduce that quantity, add sand, or you can change that proportion. Suppose your party is having high chloride content. So use minimum, use other thing also. In this way, you have to adjust 0.1% for pre-stress concrete by weight of the mix and reinforced concrete 0.3%. Coming to the chloride iron, there are 4 permeability. Air permeability in bridges, not more than 2.5%. In bridges, not more than 2.5% as per 1714 section. In case of concrete road, not more than 3%. Air permeability. Water permeability in case of bridges, not more than 25 mm. Where it is written on the deck slab, when you put water 4 hours on the deck slab, not more than 25 mm water should penetrate. So we have to check the water permeability. It is written here also. Chloride iron permeability, chloride and carbonation of also. You can check with the dye test, potassium permanganate, how much depth it is going on. So these are the tests which I am showing you. If suppose you are doing a pile work, minimum grade M35. Minimum, so these are the things the material engineer has to check at site. Maximum, here it is actually, there is a mistake in the next. It is not minimum, it is maximum water cement ratio 0.4. Maximum 0.4. Slump, pre-cast, you are doing this much. If you are doing cast in situ, this much. So all the details are given. On the top, you will find the cross-section, page number also, you can check that also. Now, if you suppose you are using epoxy, it must have 24-hour 60 megapascal strength. Or how you check? Put a drill a hole, put the steel rod in it, pull with your spring. This we are using weightlifting spring machine also. Lift that, and you can check how much strength you are getting, bone strength also, or compressor strength also you can check. Or as a simple way, take a broken beam, join with the epoxy. If you are joining with the epoxy, after 3 days, if you do the beam testing, it should not fail at the point of the repair. It should fail somewhere else. Otherwise, its strength is not more than 40 mega. This way also we can check also. These are the epoxy. Now, steel, coming to the steel bar, IS 1786 code says you cannot weld TMT bar, deform bar. But somewhere we have to go, like pile foundation. If you are doing a 2 steel bar, you have to give a lap. The lap will not work. You do welding of the 2 bar. If you are doing welding of the 2 TMT bar, you have to find carbon equivalent test as per mode page 530. The carbon equivalent must be less than 0.53. You have to find manganese, chromium, these, and find out the carbon. Then you can go for welding also in the case of TMT bar. Most important test at site, mass per meter. You please refer IS 1786. And second thing, suppose if you are using FE 500, yield strength must be 500, but tensile strength should be 8% more. Sometimes it is passing in the yield strength, it is failing in the tensile strength. So please refer tensile strength, yield strength both, and mass per meter. These are the 3 important tests for steel bar. So please refer this also. The other thing, most important test is a setting time of concrete. It will tell you when to, up to what time you have to use needle method, up to what time you can transport the concrete. What is the time? We take a concrete, we take this plunger, it is given in IS It is given in IS 516. Correct? It is given in IS 516. Put the plunger on the fresh concrete. When it penetrates 25 mm, you will get some reading here in kg. 1 kg, 2 kg, 3 kg, 4 kg. Reading will come here. Load divided by plate area. Load divided by plate area is called penetration resistance. If penetration resistance is 3.5 megapascal, it is the initial setting time. If 27 megapascal, it is the final setting time. If you don't have this apparatus, very simple trick, make a concrete ball, break in your hand, till it is joining together, it is the initial setting. Roughly, it is 5 hours. As per IS code, setting time of cement is 30 minutes. Please remember, initial setting time, but setting time of concrete is 300 minutes. 10 times more, you can say, correct? So 5 hours, you can, within 5 hours, you can transport the concrete, you can use needle vibrator, you cannot do joint cutting, you cannot open the formwork, you can do initial curing. When final setting occurs, suppose you make a concrete ball in your hand and break it and join it, it will not join after 400 minutes. See, after 8 hour or 12 hour, final setting time occur. If you put a nail, you cannot do nail marking. So at final setting time, you can start joint cutting of the concrete road. You can open the forward. You cannot use needle vibrator. This is the most important. It is given in 1710 also and 1000 in bridges also up to the initial setting time of concrete and final setting time of the concrete. Now, coming to the homework, suppose you are doing girder casting or somewhere, when to open the shuttering. One is shuttering, other is a formwork. What is the difference? You can see wall, pier, abutment, column. You can open within 12 to 48 hours as per MORTH 1500 section. Girder prop left after 7 days, but you have to put a central propping. You cannot lift that till you get the 28 distance. Props left under the girder 21 days. So this is the time for the, when they achieve this much strength, you can open that. Coming to the wearing code. In the wearing code nowadays, there is a big problem. Shall we put mastic on the top or shall we put mastic? This is a picture of the, I think, L&T project Garden Reach area. This Calcutta Metro project. There was a dispute between the consultant, contractor and that. First, they put mastic at the bottom and BC on the top. Even same thing happened in our Yamuna Expressway also. As per 2001 Morth book, before 2013, it was written first put mastic without coarse aggregate, then put BC. So we did that. The people say, raise question, no, mastic is always put on the top. So in this project, on 50% portion bridge, if you see here, mastic is on the top, BC is on the down. In the another 50% portion, so this thing you should sort out in the when you are making schedule B in the highway project. The minimum thickness, now here, if suppose you are putting a BC on the steel girder, that is not given here. Suppose I am having a composite bridge. Suppose like we are doing a Uttarakhand project, Dogra Chatti, we were having a steel deck slab. How much thickness we should put? Now in the revised Morth book, we have put that also, put a chicken mesh and then that also. Glass grid also, it was not there. Now because everywhere glass grid is also being used to avoid cracking or as a waterproofing layer. Here one question somebody can ask. Here we are putting weaker material over the stronger material. Why it is so? Normally code says you cannot put weaker material over the stronger material. Here the E value of bituminous layer is 3000. E value of concrete is 30,000. Here the material is not for structural purpose. Here the material is only for a wearing code. If it is a structural, then we cannot. Same thing on the case of shoulder also. On the shoulder, below is a GSB. Top you are putting a soil. So it is not, it is the other than the carriageway portion. So we can go for that also. Now regarding, suppose there is some fault here, this is a damaged girder. How to repair it? So make two holes here also, put some extra reinforcement. Then this is the extra dot one is extra. This is called concrete jacketing, column or a beam. Or you can go for steel jacketing also. One steel plate here, one steel plate here. Or nowadays you can put FRP plate also. One FRP plate here, one other. Or single FRP. You can cover all the three sides with FRP plate also nowadays, because it is available. What is FRP plate? It is a bulletproof car. The body of that outside body, it is a bulletproof. Like aircraft outer body is a FRP, fiber reinforced polymer, 60% fiber, 40% epoxy. There is IRC, I think 137 code is also their own FRP bars. In coast area, we can use that. Our third method is shortcrete also. We can go for shortcrete also. Shortcrete also we can go for that to further replication. We can go for shortcrete. One is shortcrete, other is gunite. Gunite means dry mixture. Shortcrete means wet mix. So we can go for a short. So these are the different method. Or this is the Yamuna Expressway. The people burnt tires. This is the Mathura section. So we did jacketing also in the pier. Now, if you are doing quality control, some parameters are given for hill road, some parameters are given for rolling. How to decide what is plain road, what is rolling road, what is mountain road? How to decide what is the correct slump? It is given in IRC 52. IRC 52 is a geometric design of hill road, and IRC 73 is a geometric design of national highway. IRC 52 geometric design of hill road, and IRC, this is given here also, you can see here, page 26, you can see here. So this is the guideline, hai na? 26 page. I enter here. You can see camber should be given towards the hill, not towards the valley. You can see that. If camber is to be given, it is given not towards the valley, it is given towards the hill. Side drain. Here there is no drain. Another thing, this is a picture that also. Just 1 minute. You can, this is the slope given here. If slope is 5.7 degree, it is a plain road. 10 meter by 1 meter. 10 meter by 2.5 meter rolling, like ROW. We have different for different purpose. Right? If slope is 14 degree slope, means 5.7 to 14 degree. It is called rolling. If slope is more than 14, up to 60 degree, it is a steep terrain. In a, means maximum 31 degree slope, our paver roller can work. If it is above 31, it is difficult to construct the road in a normal manner. So these are the things which I am just going to show you. So how to find what is the meaning of 5.7? If you take 10 theta, 10 theta is perpendicular upon base. Hai na? So it is coming 1 upon 10. So 10 meter by 1 meter. If you take 14 degree, if I take 10, 14 degree value, you can put in your computer, mobile also, you will get 0.25. So 2.5 divided by 10. So 2.5 meter height, horizontal 10 meter rolling. If 10 meter by 6, more than 2.5 up to 6 meter, it is a steep terrain. So this is the thing. Now, regarding value engineering now, we have 3 IS code, IRC code, and 1 IS code also. IS 383 now covers how to use marginal material. What are marginal materials? Are a waste material, process material. There are 3 codes, IRC 121, IRC SP 121 on steel slab, IRC 121 on construction and demolition waste. It is written here also, IRC 121. IRC SP 121. There is one more code, IRC SP 132 on industrial waste. So now, in common in all the 3 code, what is written here, in lean concrete, you can use 100% marginal material. In lean concrete, in TLC plain concrete, 50% marginal material, 50% natural aggregate you can. In RCC structure, up to M25, you can use 25% as per IS code. So please refer for that IS 383. Coming to the self-compacting concrete in case of bridges and nowadays roads also, there is a IS code now. Earlier we have different code. Now IS 1199 part 6 covers the self-compacting concrete. What is the difference between self-compacting and conventional concrete? Only VMA. If you put VMA in the conventional concrete, it is a flowable concrete, pumpable concrete. Now regarding difference between pumpable and self-compacting is the same. Pumpable concrete, no VMA. It is the same flowable concrete, but in self-compacting concrete, VMA is a must. And these are the specifications which are given in IRC SP 70 code on the bridges. we can use for pile foundation, most important, but because there which is compacted by the self weight of the aggregate. So simple two test, pre-funnel test. If you put, now there is a question, can we use steel slag in concrete hot mix plant? What are the, actually it was given, sir, just 2 days back when we were revising the code, section 500. So it is written in the Morth book, yes, slag is permitted in the, but it is still under discussion. Now we have, I think, we are deleting this portion, use of slag in the bituminous mix. The reason is there is sometimes sulfur. If sulfur is not there, the another thing is you can use slag cement provided it is conforming all the aggregate specifications. Now we have put in the revised, because I am a member for that working group also, where we are revising Morth book also. What is written in the GSB also? You can use 30-50% marginal material, provided you should follow the grading or some specification which is given in this code or other code. The coder provisions are required. Right, sir? So anyone has any question, you can put on the chat also. I will try to give answer for that. Now, if suppose you are doing MIG design, for this chart which I have shown you, this chart which I have shown you for the MIG design, this is only up to M70 grade concrete. Suppose I am designing a girder for M80 grade, they target 70. Means this is only up to M50 or M60 grade concrete. Suppose my grade is 65 or 70, I cannot use this chart. For that, what IS code says, you have to use this chart for getting the water cement ratio. This chart which I am showing you, this chart. If your target, this is the copy of IS 10262. Above M70 grade, if you have to use HRWRA, high range water reduced admixture, yani super plasticizer. Without super plasticizer and VMA, you cannot construct 1026. Then here you can go, maximum water cement ratio is 0.36. Minimum water cement ratio is 0.24, not 0.25. The difference only between the high strength concrete and normal concrete below 70 is only the aggregate size. Here it is better if you use 10 mm and 12.5 mm aggregate. If you are using high strength concrete, the water cement ratio not depends on the type of the cement. It depends upon the aggregate size. Please remember. In the high strength concrete, if your nominal size is 10 mm, then water cement ratio is 0.36. If 12.5, if you are using say 20 mm, then you have to put more cement. Less water cement ratio means more cement, water cement ratio. No. Sir, can we reduce water cement ratio below 0.28? Yes. Even IIT Delhi, they have gone water cement ratio 0.15 or 12 also. I will tell you. They have gone below point. Then I asked the question, T.C. Bhattacharya sir was there. He was the head civil engineer at IIT Delhi. I said, sir, why you are making 0.12, 0.15 and you yourself have written in the code, sir, it should not be less than 0.24. Then what he explained me, he said, in the case of above M70 grade concrete, you cannot go for normal curing. If you break this, what will happen inside? It will totally dry. You have to go for above 70 steam curing also. Please remember, if you go for a steam curing, what is the meaning of curing? Whatever water which is there, it should remain. Now in very high strength concrete, you are putting cement mixture also. Some water is absorbed by that also. So that water reacts with it also. So we can go, provided you are getting durability and other test, right? We can go 0.18, 0.12 also. But you should justify the other properties also. And it should not be too much brittle also. That is why in the ministry circular, what they say, ultra high performance concrete you can use up to M140. Why not use, if it is a too much binder you are using, then you have to put fiber also. Ultra high means if conventional concrete, you are putting 10% silica fume, the name of this concrete is a high performance concrete. Correct? If you are putting fiber in it also, so fiber plus silica fume is called ultra high performance. High performance means life 500 years. Normal concrete life 100 years. Please remember this point also. And refer the IRCSP 70 code also. So for concrete road, sample 150 cubic meter either for DLC or for PQC. In the case of DLC, they have written 1000 square meter. If thickness is 150, so it becomes 150 cubic meter. In the case of bridges, 15 cubic meter, one sample. In the case of concrete, 10 times more. Reason? Here area is more. Here quantity is more. Here batching plant is having 140 cubic meter per hour capacity. In the case of bridges, 30 or 60 cubic meter batching plant we use. In the case of bridges, the quantity is less. In the case of concrete road, paver speed is 1 meter per minute. The quantity of sample is means frequency is less. So minimum 3 cube per day, minimum 6 beam per day is required as per IRC 15, class 12 for quality control for the concrete road. Now, if you see, it is written here also 15% variation. Now, can you ask, sir, can I ask the question? Suppose when we take FCK plus 3, what is the reason? Why they put 3? Why not 4? Why not 5? According to me, FCK plus 3 today should not exist. This is 30, 40 years old figure. When we were using 1 to 4 concrete, 15% of that, 15% of that is 3 megapascal. है ना 20 into 15, so FCK plus 3 is coming. If suppose today I am using M40 grade concrete, if I allow minus 15, what is 15% of 40, sir? 6 megapascal. Suppose I give to the contractor 6 megapascal, no problem, 40, 34, so it is acceptable. I think it should not be acceptable. My design is for M40. I am giving 15%. So today it should be, I think it should be FCK plus 6. Or while designing, please take higher target strength, then it would be better. So cost cube 150 by 150. Now see the aggregate size has increased. If you go in 4 layer, the aggregate will be 1/4 of the thickness. That is why we reduce up to 3 layer. This is the reason. Because aggregate size going on increasing. What is the reason? If you are increasing the aggregate size, it means you are putting 10-20% value engineering in the project. Your cement will be less. You will have a good quality also, whether it is a bituminous material or it is a concrete material. Grading 1 is much, much better than grading 2. No doubt binder is less, but more interlocking, less bleeding, less chances of cracking is also there. And please always find R value in the case of bridges also, I will suggest, and in the concrete road, it is a must. Suppose if you are doing a pier and the deck slab, suppose you cast a pier and you start construction of the deck slab, and after 20 days you find my pier is having less strength, then or go for a double. So in the case of concrete road, slump should be 20 to 30. If you are going a semi mechanized method, 40 to 60. If you are doing on a slope road, then 20. Now bonded rigid pavement has also come. Here, if you see, when you are testing a beam, you can check the quality with this also, not only the strength. Qualitatively and quantitatively both can be checked. If your beam fails at the center, it is called flagellal crack, very good quality concrete. If your beam fails near the support, shear crack, it is a poor quality concrete, no proper gradation. Please remember this. If your crack occurs after 17 centimeter, up to 20 centimeter, it is a medium quality concrete. So your concrete beam must fail at the center because bending moment is maximum here. Bending moment is not here. If it is failing here, it means it is due to something else. Load is not there. Why it is cracking here? Please remember. And please remember this equation also. How many people knows what is the formula for this? This m upon I equal to f upon y. From here, this equation has been developed. So there are three formulas. 90% we have seen at site. The people are not using proper equation for finding the flagellal strength for tension member. If crack occurs between the two support, then only this formula. If crack occurs after 17 centimeter till here, then this formula is to be used for finding the flagellal strength. A is the distance of crack. A is the distance of crack. If crack occurs less than 17, you have to discard. It is a poor quality concrete. You should not take this value into the average. So please, this is the beam. 150, 150, 700, 50 mm here, 50 mm here. The distance between the support is 60. And what is the rate of loading? 400 kg per minute. From where rate loading comes? Anyone? Rate loading comes from the tire pressure. If tire pressure is 7.2, if you put equal to PL upon BD square, L if you put 60, B and D you put 15 centimeter, the P you will get 400. So rate of loading comes from the tire pressure. So rate of loading should be 400 kg, 4 kilonewton per minute. 4 kilonewton per minute. IS 5162019. So please remember this also. Now simple example I am showing you how to pass how to do quality control. What is the meaning of 4 consecutive sample? Consecutive means if 2 sample from one girder, the other 2 samples should not be from the other girder. They should be from the same girder. 4 consecutive sample from same batching mix, from same batching plant. So these are the 4 consecutive samples. Suppose we are having a 18 samples, sir. Average of the 3 specimen 43. Average of 3. If you take first 4 eggs, so it is average is 44. As per IS code, acceptance is FCK plus 0.825 into standard deviation or FCK plus 3. As per IRC and IS code, Ministry's code, it is FCK plus 3 or FCK minus 1 or FCK minus 3. There are 2 options. Here it is passing. Case 2 also it is passing. Average is, if you see the yellow portion, 9 and 18, this value 32.8 is 19% less than the average. It means this is not rejected. This is invalid. What is the meaning of invalid and rejected? Invalid means when 2 samples are giving more than 40, how one can give 32 only? It means there is some doubt in the casting of the cube. It means this value you cannot take into the average. If suppose you are having 40, 44 values and one value is M20, M20 you cannot take into the average. It means you will do separate core cutting or NDT test, then you can pass or fail depending upon the result. So sample 9, sample 18 is invalid. Variation is more than 50. And individual value also. Individual value is also, if you can see here, if it is 39, it is also failing as per MORT specification also. One value can be FCK minus, that is also very less. So this how to pass or fail. Suppose your Q fail, what you will do? Then we will cut the core. In case of bridges, 50 mm dia core. In the case of bridges, you have to use perfometer or auto scanner, ferro scanner. You have to use sulfur for capping, the best material, and you can, the pan you are having, we heat the sulfur and we put a very good finishing you will get. If you go with a normal cement, your results will never pass. Please remember. If you are having a camber 2% in the road, your top, you have to cut a triangular. 90-degree must be there. If you are breaking a core or a cylinder, it must break at 45-degree. Please remember. Now, how to convert core strength into cube strength? Find height die ratio of the core. Put height die ratio here. F value you put here. Core strength into F value into 1.25 because strength of the core is 25% less than the Q. So we multiply core strength into 1.2 into correction factor, we get cube strength. Here, one very interesting thing, code says if you get 75% of the characteristic, your results pass. Is it correct? Here code says, no, your strength should be FCK plus 3. When you are doing actual work, code says, no, if you are getting 75%, if you are using a 40 grade concrete, और आपका 35 या कितना आएगा, so your sample is passing. Why it is so? It relates to the money. Because at side, FCK plus 3 I am taking because I am doing curing in the tank for 28 days. When you are taking a core, you are not doing curing for 28 days. First thing. Second thing, the traffic is also moving. Third thing, when you are cutting a core, minimum 25% strength is reduced. Please remember, if you are cutting a core, 25% strength is reduced or 20% strength is reduced. That is why they have said individual core shall not be less than 75%. Average should be 85%. And please do the cement test, concrete testing only in a wet condition, tube or a cement mortar. If you do dry, you are giving 20% benefit to the contractor. 20% results are more. Rate of loading 140 kg per square centimeter per minute or 320 kilonewton per minute. 32 ton per minute, 32 ton per minute, you have to apply the load. In the case of bridges, 50 mm dia. In the case of concrete load, PQC, 150 mm dia. In the case of DLC, the high-lean concrete, 100 mm dia. The performeter we should use wherever steel there will be a buzzer. You can check. Cover meter also you can call it. Now you see this picture is given in the code. IS 516. If you are testing a cube or core, it must fail like this, 90-degree angle. If it fails by shear, it is a rejected concrete. It is written in the code. Correction factor is also written here. This is a copy of the code. Another thing, suppose I am not having a, now in the new code, IS 516, very interesting thing has come. Depending upon the size of aggregate or depending upon the size of die of the core, you can get one value from the other also. What this code says in class 8.4.1, suppose you have to cut a core 100 mm dia. You don't have 100 mm dia. You are having a 150 or 50 mm dia. Now what shall I do? Suppose I want 100 mm result. Though they made one equation. If dia is 100, correction factor is 1. If dia is 50 mm, suppose, you have to multiply with 1.06. If dia is 75, you will multiply with 103. If suppose dia is 150 mm, then 0.94. So I made one equation also. Dia plus 830 into factor equal to 93. Suppose dia is 100. If dia is 100, so 33 minus 100, 833, factor is 1. You can calculate with this also. In the case of bridges, 2.5% air void. In the case of concrete road, page 434, every 2 kilometer, how to find theoretical density. In the case of concrete road, in the case of bitumen road. In the case of bitumen road, we call it GMM. What is the difference between GMM? What is apparent specificity? What is actual specificity? What is bulk? What is density? So now I am going to explain you this. Density means dry mass of the core divided by pi r square. This is the density. Bulk density is a separate thing. Like bulk density of cement is 1440 kg per cubic meter. Ready loose material. If you dip this core in water, it is called specificity. But this is not happen in the case of bitumen road. In the case of bitumen road, if you dip bituminous core in water, it is not specificity. It is apparent specificity. Well, it is looking like it is not actually that. In the case of concrete road, all water goes into the voids of the aggregate also. Whereas in the case of bitumen, when you dip bitumen in the water, the void in the aggregate, they are not filled with water. In that case, we find the theoretical specificity, either through the mid or with vacuum, we put water inside. I am showing you one small video how to do. In the case of bitumen, I think most of them, this is the equipment we use. We suck water. So from the inside aggregate, the water is sucked. The water goes, so that water replacement we take it. So dry mass divided by actual volume of water, which is the GMM. How to find GMM? There are 2-3 methods. One method is practical method. Sir? So you have to put a pressure of 30 centimeter or something here also. We put the pressure here also. So then, or we can put the formula also. 100 divided by percentage of coarse aggregate, specificity of coarse aggregate. As per MS2, you can find GMM also, for concrete also. The third is Joe mix formula. In the Joe mix formula, you know each and every item. Other than the air, whatever is the mass or volume, that is the GMM. So there are 3 methods. And or how to find percentage of void. Specificity, minus density divided by specificity into 100. Specificity minus density divided by specificity into 100. Because in all the three cases, your dry mass is constant. Difference is only of the volume. So these are the things I am showing you. In case of bridges, please refer page 186, 192. There are 3-4 NDT test, ultrasonic test, rebound hammer test. I am having rebound hammer with me. I don't know whether it is a visible here also. We can use rebound hammer. It is hardly 20,000 cost. Or maturity meter is the most important for the bridges and for concrete road. What is maturity meter? If you put a mobile-like material on the structure, every hour you can find out the strength. Means megapascal hour. Maturity is a compressive strength into time. ESTMC 1074. This is a copy of the IRC 112 code only. And if you want, I can just show you that also. 128 page. Is the durability. In this, for quality control for bridges, please refer all these things are given here also. And fly ash, maximum cement. If you see this picture, is it visible, sir? OPC cement is permitted only when chloride sulfates are. There are two tables. One is this table. Who will tell what is the difference? One is this table. Sir. What is the minimum cement? What is maximum water cement ratio? This is one table. Different conditions are given. On the next page, IRC and Morse both code says use this table. Here they say no, use this cement. What is the difference? Anybody can tell. What is the difference in these two tables? What is superstructure? What is substructure? This is the difference here. Any structure above bearing is a superstructure. Anything below bearing is a substructure. It may include foundation, it may not. Any foundation work, any structure touching the ground, this table is used. Any structure, pile cap, pile, this table is applicable. Any structure touching the ground, minimum cover 75 mm. If chloride sulfates are more, maximum fly ash in PQC is only 20% till now. In IRC 15, 25 has come. Now in the revised Morse book, we are increasing up to 25. There was some legal case also from cement company to us when I was a co-convener. The why cement company saying 35, why you are putting 20? When I was working in Yamuna Expressway, 14th January was the day. We were using 25%. After 2 days, concrete was not setting. In the case of concrete road, the problem is joint cutting. If you will not cut joint within 1 day or 2 days, due to warping, crack will occur. If we add 35% as per IS code, yes, we should follow IS code. But that IS code is applicable for everywhere, for flooring, so we have to think strictly. So we have allowed only 20-25%. However, in the case of bridges, because formwork is there, in our case, it is an exposed structure. So we cannot allow more than 25 as per our mutual discussion. So you can see here, you have to find if any structure touching the ground, you have to find chloride and sulfate in the soil. 2 parts water, 1 part soil. If chloride sulfate is 1.9%, OPC cement is permitted. After 1.9, OPC cement is not allowed at all. In coastal area, Visakhapatnam, Chennai or Bombay, within 10 kilometers from the coast, we have to use Portland Pozzolana cement, slag cement or silica fume is a must. They will help you as per the code. So this table we have taken from there. So this is maturity meter, pull out test, bullet test. So these tests are given there. Please refer that as per class 18.9.9 IRC 112. If everything fails, in bridges, suppose core fail, Q fail, NDT fail, what is the last option? It is given in 18.9.9, only load test. If after load test IRC SP 51, if recovery is 75 or 85%, you cannot reject the girder or the structure. Last step for the acceptance criteria is the load test. Correct, sir? So these are the tests already we have given. This is IRCSP 51. Any crack in the structure should not be more than 0.3 under loaded condition. And for pre-stress, recovery should be 85% when you apply the dead load plus 25% the live load on the structure. Correct, sir? Permeability, you can see here 25 mm. MORTH 1700, maximum water permeability 25%. So please follow this also for quality control. Now, new thing which has come in IRC 15, they say age factor is not permitted. However, Morse book says age factor is permitted. Now, in the revised Morse book, we have deleted age factor. If you are cutting core, so now if you are getting 85, 75 in the CC road, as per IRC 15, class 12.11.4, please see the red portion, age factor shall not be applied on core while determining distance. Because 90% cases, we are not getting the actual result. So concreting in hot weather, I think everyone knows the ambient temperature not more than 35, minimum temperature not less than 10. Any crack on the panel, total length, now 300 mm is permitted. Any shrinkage crack, as in a PQC 4.5 meter by 3.5 meter, 3000 length is permitted. So these are do's and don't. Few slides are left. These are left side the do's, right side don't. Suppose you are going for a compaction factor test for the soil or a GSB. Code says 250 mm thick you can go. Is it correct, sir, to go for 250? If you are going 250, which is given still in the Morse book, it may lose you are taking 300 mm. So what we discussed in the one Morse specification, suppose we are putting 300 and finding compaction factor of only 100 mm, 150 mm only. Second thing, MDD you are finding for 19 mm. And code permits you 50 mm and 75 mm also. In the case of GSB also, when you are finding MDD, you are taking 37.5 mm, whereas you are using 75 mm or 53 mm aggregate. So my advice is, if you are finding compaction factor, oversized aggregate shall be removed, or find MDD with the same material, not with the that one. This will give you some better. And the second thing, if now in the revised Morse book, instead of 200, 250, better go 150 or 200, particularly when soil is clay, silty or that. It will give you better result. Because free swelling index is allowed is 50%. In the revised, we have reduced 40% now. Suppose 6 meter is the embankment. So when it was wet, you did the construction. So as per theory, it can go up to 3 meter. So whether K value will take first. Second thing, this I am telling you based on my practical field experience, what precaution you should take. 90% people, what they do, whenever the prime coat, tag coat they do, whenever the brown color converts into black, they start putting the top layer. That is wrong. What is happening? Top it is black, but if you put some blotting paper, still water is there. When you put 140-degree material, it converts into steam. So please wait after 4 hours more. Even epoxy also. If you are using epoxy, wait for 3 hours till it gets the bond with the bottom layer. है ना? If you need a better riding quality, most important part, only two: minimum stop and start of the paver, actual gradation, you will 100% get good riding quality. The main factor, it means oversized aggregates are not being removed by the plant. Over fine particles are not being removed from the plant. Aggregate is not properly graded. You are not properly cleaning the machinery daily. With this, you will get very good riding quality. Regarding core cutting thumb rule, if you are cutting a core, if it takes half an hour, it must be M30. If within 10 minutes core is in your hand, it may not be M40 grade concrete. Similarly, soil also. If you are cutting a core from the soil for density, if you take after 10 hammers, it means it is a 1.75 density you are getting. If suppose within 2 hammer, you are getting the soil core, it means there are chances of getting the. If you put a concrete, anywhere, it should not absorb more than 2% water or 3% water. If it is absorbing 2 or 3% water or 5% water, it means it is a weaker concrete. During mid-design also, please remember, code says, yes, he is a contractor generally doing this, but it is his, suppose I am looking after one project, cover the many projects, everywhere what is, suppose one project I was looking at Dilip Bilkon project in Kharagpur, next year concrete road fail. They were doing some short panel payment there. What I saw there, I asked the person at site, sir, why this road failed, sir? Next day, heavy rain was there. It was a heavy black cotton soil area. So it swell, though after shrinking is reduced. So what we should do, the first and foremost point is, very black cotton soil is there. Please go thickness, even approaches also. If you see today, all contractors are very good contractors. They are working for a longer period. Why every time failure is there? Why every time failure is there in RE wall, everywhere bulging? So now we have revised the code. Now, earlier what was written, in place of filter media, you can go geocomposite. Even in reinforced GSB also, most of the contractors, they have started using geotextile in the GSB, geotextile in the WMM, and they are reducing DBM. The roads are not surviving for a longer period. Now in the revised Morse book, we have added both. Yes, you want to use geocomposite, use, but with filter media. If you want to use GSB in the geotextile, that will be additional. You cannot reduce the thickness based on D, but this is under consideration. Till it is finalized, I cannot say anything. So this will help you, sir. If you go for a lower layer, any undulation in the lower layer, ground level, 90% people, if you do proof rolling, you will 100% get very good riding power. Many people say in their mind, they have a thinking, sir, I am having a very good paver. We are having a sensor. Sir, it will uniform give you my thickness. No, that idea is wrong. Whenever there is suppose undulation in the ground level, each layer you will find undulation. When you are putting a bituminous or a concrete, when you are putting this, it is in a liquid state. It will take the shape of the bottom layer after half an hour, 1 hour, and permanently set there. Your riding quality will be affected. So please do proof rolling. Please check evenness as given in the more section 900, unevenness, longitudinal and transfer direction, both 5 mm, 6 mm, each layer, whatever is given, please refer that also. So for mid-end purpose, I will tell you something we are doing some mistake in the code. In the code, what mid-end code says, if water absorption is 2%, they say the mid-end is on the SSD condition. Whatever water is there, they say add into the water. So this water absorption is for 24 hours. Will your concrete wait for 24 hours for the chemical reaction? Suppose my water absorption is 2%. My cement is 400. So 2000 is aggregate. So 2% of 2000 is 40 liter. 40 liter water I am adding in the water, and I am saying my water cement ratio is not being changed. I think according to justice, what we should do, there are two options. If you really become a Mahatma Gandhi, then put water, take wet aggregate. That we can do. Or find water absorption for 3 to 4 hours for mid-end purpose. That water absorption you should take into the mid. This is my personal suggestion. Either take wet, if your water absorption is half or 1%, do as per the codal provision. If your water absorption is 2 or above 2%, in that case, it is advised either wet the aggregate, then that water will not react with the cement, or take water absorption for only 3 to 4 hours. These are do's, these are don't. So please refer the PPT in detail. I think this all you may be knowing. I am skipping. Fly ash will give more strength than concrete without fly ash particle. I fully agree with fly ash, strength will be more, but after 90 days. You will get better strength after 90 days, not before. You have to compromise. That is in all PMJIS road, we have suggested design for 90 days. Reason is if you are using fly ash also, that can. In the case of bridges, 35% is allowed. In the case of concrete road, 20. Now they have increased up to, I say, 25% also. So these are the specification already. I think everyone might be knowing. Liquid limit, PI, I think all seniors are there as I came to know from Rana ji. So now here also, one drawback is there in the case of GSB now. Now we have revised the Morse book. At present in the revised Morse book, in the original 3 and 4 is written as a filter layer. And you can use any weak material also. 5 and 6 as a drainage layer. This has been revised in the Morse book as per IRC 37 present or IRC 15 also. The present IRC 15 and IRC 37 says 3 and 4 should be used only as a drainage layer. Now we are using, because it is a gap graded, it has been checked by at Rasta. Kavita madam, she did some research, and what she found, we are getting permeability 3000 of grading 3 and 4. So it is better if you use 3 and 4 as a drainage layer, 5 and 6 as a filter layer, 1 and 2 as a CTB or CTSB. Grading 1 and 2 is a well graded. 1 and 2 can be used CTB or CTSB, 3 and 4 drainage layer, 5 or 6 filter layer. And these all specifications are given here also. Same thing for PQC. For PQC, you can see, sir, as the Morse book, 20% fly ash is permitted. Now in the IRC 15, 25%, 5% they have increased. If it is a process fly ash, good quality fly ash, we can go more also. But we have to check. Minimum cement 150. As per IRC code, they have reduced, I think, 120 or something. But in the Morse, we have not changed at present. In the IRC, 7 megapascal is given or 7.5. But that also we have maintained 10 megapascal because we are going bonded also. So we are not changing the specification too much. And for rigid payment, as per IRC 15 class 12.8, FCK plus 3 average and 1 FCK, then minimum example 39. And to convert compressive into flexural, take square root of the compressive strength, multiply by 0.7, you will get flexural strength, modulus of rupture, tensile strength, beam strength, same meaning. Minimum 4.5, acceptance 4.8. Acceptance 4.8. One sample can be 4.2, 4.5 minus 0.3. One sample average can be 4.2, average should be 4.8. Minimum dia of the dowel bar. Dowel bar should be used when minimum thickness is 200. From this table, tie bar, dowel bar table, minimum thickness for national highway or PQC shall be minimum thickness for DBM for minimum thickness for PQC is 200 mm, correct? Because for PMJSY thickness is minimum 200 less than. So we are not using dowel bar. Load is not there. The dowel bar technical name is load transfer device. So in PMJSY, because load is not there, we are not using dowel bar at each contraction joint. But in national highway, everywhere we are using. And the another thing is there is some technical, every contractor wants, they don't want 36, 38 mm at site wherever it is required. Like for 300, we need 38. So most of the consultant, they are discussing why not 32. So they are designing as per actual. These are the default value. You go for actual design, whatever value you get. If you suppose there is small work, you need default value, you can use that. So minimum thickness for national highway is 200 mm PQC minimum, whether it is a bonded or unbonded. In the case of other road where tie bar is used, minimum 150 can be used. So this table shows you the minimum thickness permitted also. Suppose you are making road at the approaches, you have to use fiber also. You have to make RCC. Slump should be 20 mm. No polythene sheet. You have to go for a bonded. At super elevation and at approaches. IRC 15, page 63. This is given there. Please follow on hilly area, curve, slope, approaches. Bonded rigid pavement as we have done in Bakhtiarpur project also. If you are using tie bar, please remember variation not more than 10 mm in a rotational way, 50 mm up and down, and depth plus minus 25 mm. IRC 15, class 11.5.2 at the bottom, alignment of the dowel bar. Dowel bar means kunta, wedge. If your wedge is not horizontally, you cannot hang anything. And for standard deviation, you can see in the case of rigid pavement, we take 4.5 plus 1.65 into from where 1.65 figure has come. 1.65 if you take, it means it will be the characteristic strength. Failure 5% is permitted. In the case of concrete road, you have to design based on the flag strength, but you have to cast cube also. Both cube and beam should be cast. Main parameter is flag strength, not the cube strength. Regarding stability, you have said 12 kilonewton. If you are using a modified bitumen, then you have to take 12, otherwise 9 kilonewton we take the stability. So now few slides I will show you. राणा जी टाइम अगर परमिट है तो 5-10 स्लाइड वो दिखा सकते हैं. हेलो
Sir, actually the VC slot is for 2 hours, sir. So can we have the question? If you are concluded, then we can have a
चलो
question
just
answers.
few slides, just 2-3 slides.
Yes, sir,
Regarding
please.
sir, earlier we were using VG grade bitumen. First, all number they have some meaning. If you multiply this number with 80, you will get the viscosity. You will get the viscosity. If you multiply with 120, you will get the another viscosity. You can see it. 80 into 10, 800. The maximum, if you multiply with 120, you will get the highest viscosity. So please remember, earlier we were using VG grade bitumen. Its softening point was only 50 degrees centigrade. Today pavement temperature is 80 degree. Now we are not using VG, we are using a PMB grade bitumen, PG grade bitumen. This is IS 15462. PG grade, they are defined by two number. First number is the pavement highest temperature. Second number is the pavement lowest temperature. So based on the pavement temperature, there is a ministry circular also. We are going for that. For PMB, this is the ministry circular. So as per the MORTH, please use this. Which type of bitumen should be used where, and median should be done as per IRC 132. Please follow all the schedules also. So I think I will not. Now lab also in IRC SP 112, how to make your lab vertical, what is the size of your, where to put which equipment, all these things are given there. Calibration also, calibration given is also in this IRC code, like plant, who will calibrate every 3 months, in-house, external, one, anything calibrated externally 1 year, everything calibrated in-house every 3 months. So please refer table 7.4 for this. And in this case, tables are also given, how to make testing laboratory, frequency is also given. This is dowel bar scanner also you can use there also. This value is 1.65 into standard deviation if you use. So now maintenance. This is on the deck, sir. We are putting a APP sheet, a tactic polypropylene sheet. Earlier we were using mastic, sir. Pier of 20 meter high. So we will. So any structure whose length is 3 times the thickness will act as a compression member. All national highway paver block we are using 80 mm. Concrete road 300. Thus length, if it is 3 times the structure, all paver block length should be 3 to 4 times. Minimum M40 grade for national highway. Then finally unevenness and network survey vehicle should be used for the calculation work. The last slide I will show you how to make homogeneous section. So this I have taken from the ASTO specification. One side chainage, other side values. If you take the value, find the average. If you measure the average, subtract each average from the each value, average from the each value, then take the cumulative sum. Cumulative of difference average minus measured value, then you will get 3 channel. So 3 homogeneous section you will get. It is called QSUM method. So it is a very good method. One axis chainage, like you will get even 2 uniform section. One is coming at 12 CBR. This is also, so 2 section we go 20. How to make homogeneous section? I think this will help you when you are using FWD or others. Again, I am repeating X-axis chainage. then CBR 15, 15 minus each value, then cumulative of this minus 7 minus. And you take cumulative, now draw the graph between cumulative sum and the chain age. Cumulative sum and the chain age. So one section, two section, three section. Then we can have the CBR also. Frequency is also given here. Roughness has increased now. This is the last. Now we can have the question answer. Okay, sir. So
Yes,
there
sir.
were so many questions, but I cannot. Now you
Sir,
can raise your question, please.
VC admin, please unmute all.
There were few questions, but
Now everybody has been unmuted, sir. Few questions we can take quickly, sir. Yes, sir.
बोलिए सर, शमशेर आलम सर।
जी सर, मेरा कहना है सर कि पीक्यूसी रोड में अगर मेन क्राइटेरिया अगर फ्लेक्चरल टेस्ट है तो उसमें क्यू क्यू कास्ट किया जाता है।
इसमें किसमें सर, इसमें
अगर पीक्यूसी पेमेंट वर्क में
हाँ जी,
मेन क्राइटेरिया फॉर एक्सेप्टेंस ऑफ द टेस्ट इज फ्लेक्चरल टेस्ट,
हाँ,
देन व्हाई वी आर कास्टिंग द क्यूब्स।
वेरी गुड क्वेश्चन। देखिए, why we have given cube also, this we discussed in our meeting also. Reason is, when you are casting beam, there are chances of not getting accurate results because its weight is very heavy. Suppose the person who is filling cube and mold and casting and opening the formwork, he is not so intelligent. He may not be knowing something. Suppose he lift the beam with a force he put on the ground, so you will find some hair crack. So there are chances of some not proper result. So that is why we said we must confirm with the cube also. This is the only reason. Otherwise, we can go further. Because even in the code, IS code also, if you see IS code also say, IS code, you first priority should be given to the cube. So we are following IS code. IS code says your priority should be cube, not the beam. So that is why we are going cube and beam both, sir.
थैंक यू सर।
Otherwise, you are right, sir. Either you are right, sir.
सर ये पीक्यूसी में जो स्टेपलिंग प्रोसीजर जो सर आपका स्लाइड एक मिस कर गया था सर, एक बार रिव्यू करा दीजिए सर।
अच्छा, सैंपलिंग जो भी होमोजेनियस सेक्शन का,
हाँ सर, स्टेपलिंग पीक्यूसी रोड में
होमोजेनियस सेक्शन की बात करें ना सर,
लॉन्गिट्यूडिनल सेक्शन सर। आपका स्लाइड सर फास्ट चला गया सर, उसको एक बार रिव्यू करा दीजिए।
अच्छा, नहीं इसमें तो शेयरिंग तो आ रहा है, मैं स्लाइड नहीं आ रहा क्या सर?
नहीं सर, स्लाइडिंग थोड़ा लास्ट में सर, फास्ट में आपने मतलब स्किप कर गए स्पीड में। तो
मैं यहाँ से तो स्क्रीन शो कर, मैं स्टॉप करके दोबारा करूँ सर? एक मिनट
सर, शेयर्ड है आपका स्क्रीन।
अभी मैं दोबारा कर देता
स्क्रीन शेयर्ड है सर, लेकिन जो आपका सर लॉन्गिट्यूडिनल क्रैक ऑन पीक्यूसी रोड ऑन द प्रोसेस ऑफ स्टेपलिंग।
मैं सर आपका तो नहीं समझ पा रहा हूँ क्वेश्चन, किसके बारे में आप पूछ रहे हैं सर?
पीक्यूसी रोड में जो लॉन्गिट्यूडिनल क्रैक होता है और उसका स्टेपलिंग जो प्रोसेस जो आप एक स्लाइडिंग है
स्टेपलिंग, अच्छा स्टेपलिंग वाला, अच्छा ठीक ठीक ठीक,
जी सर।
समझ। इसके बारे में टाइम की वजह से मैंने उसको स्किप किया सर, उसमें कोड में चेंज आ गया वो। एक मिनट सुनो, ये देखिए इसके बारे में सर पूछ रहे आप?
जी सर, जी सर।
है देखिए, पहले इसमें एक चीज समझ लो अच्छी तरह, मैं थोड़ा रिजिड के बारे में थोड़ा बताता हूँ सर। देखिए, पहली बात तो मोस्टली कंसल्टेंट क्या करते हैं, कोड के हिसाब से एक तरफ से लिखते हैं कि IRC SP 83 फॉलो करो, है ना सर। दूसरी तरफ कुछ कोड में कुछ यस करेक्शंस की जरूरत है। अब 83 में ये भी लिखा है कि मोर्थ में भी लिखा है कि जैसे ही आपका हाफ डेप्थ से ज्यादा क्रैक है रिजेक्ट कर दो, कहीं लिखा हुआ है अफेक्टेड पार्ट को हटा दो। लेकिन अगर आप क्लास 4.6.4 देखेंगे, मेरे हिसाब से वो जस्टिफाइड ज्यादा ठीक है। उसमें क्या लिखा हुआ है, फुल डेप्थ रिपेयर जब सीवियरिटी 5 होगा। पहले सीवियरिटी का मतलब देख लो क्या, सीवियरिटी 1 मीन्स 10% क्रैकिंग, सीवियरिटी 2 मीन्स 20% क्रैकिंग, सीवियरिटी 3 मीन्स 30% क्रैकिंग, सीवियरिटी 5 मीन्स 50% क्रैकिंग। If something is more than 50% distress, crack more than 20 mm, faulting more than 20 mm, one panel broken into 4 or 5 pieces, slab, or rocking, that panel should be removed. Up to severity 2, it is acceptable. But earlier, what was written, now coming to your point, it was written everywhere, go double bar retrofitting, double bar retrofitting. Now that class has been deleted from revised IRC 83 2018. 8 में था वो, 18 में क्या लिखा है, 7.5 में, इसको ध्यान से पढ़ेंगे कि ओनली क्रॉस स्टिचिंग एवरीवेयर। इसको मैं दोबारा, क्रॉस पिक्चर ऊपर बना हुआ है, क्रॉस स्टिचिंग क्या करना है, देखिए, both method of cross stitching and slot stitching meaning double bar retrofitting are effective in preventing the widening and maintaining agreed interlock at longitudinal joint. Otherwise ट्रांसफर में भी अब आपको ये भी करना है, इसलिए पेरीफेर में पूरे में करवाया मैंने। However, cross stitching has following advantage over double bar retrofitting. Cross stitching is less intrusive, less damage to the structure. ओरिजिनल मटेरियल को मैक्सिमम रखना सर, जो ओरिजिनल मटेरियल है वो जितना ज्यादा रहेगा उतना बेटर है। रिपेयर्ड सरफेस एरिया एक्सपोजर इज लेस, ओनली ड्रिल्ड सर्कुलर होल करना है, क्वांटिटी ऑफ द बैकफिल इज लेस, सो क्रॉस स्टिचिंग इज लेस एक्सपेंसिव रिपेयर, कॉस्ट भी देखनी है। इस एडवांटेज की वजह से सब जगह आपको क्रॉस स्टिचिंग ही करना है। इसको, इसका एक वीडियो भी शायद अगर एक मैं दिखाऊंगा आपको, तो इसमें शायद ये देखिए क्रॉस स्टिचिंग, ये बनारस के प्रोजेक्ट में किया था मैंने। देखिए ये दिल्ली बिल्डिंग का प्रोजेक्ट था, ये देखिए एक क्रॉस, एक होल किया इधर, एक इधर होल किया, देखिए सब जगह कहीं भी क्रैक है, दिस इज द बेस्ट मेथड। लो विस्कोसिटी इपॉक्सी लेनी है, टाई बार लेना है बस, क्योंकि वो सरिया डालना है, 150 mm डिस्टेंस से 50 डिग्री एंगल पर कील डालना है। देखिए अब आपको, और दूसरा टोटल क्वांटिटी ऑफ इपॉक्सी शुड नॉट बी मोर देन 1 or 2 kg, और डू अर्ली मॉर्निंग, इसमें हीट जनरेट होगा। ठीक है, ये देखिए अब ये दोनों होल को इपॉक्सी से भर दिया। नाउ वी विल पुट स्टील बार, टाई बार, मतलब कम से कम 40 सेंटीमीटर लॉन्ग, तो प्रोडक्ट के थ्रू चला जाए। ये देखिए टाई बार लगाया ना, अब ये उधर से इपॉक्सी नहीं, एयर निकलने के लिए आपको स्पेस चाहिए। अब इसमें करेंगे वो, फिर एक इस साइड तो क्रॉस स्टिच करना है दोनों साइड में, थोड़ा सा आपको छोटा है, थोड़ी सी अंदर करना पड़ेगा। चलो अब इसको डालो, ये बनारस का प्रोजेक्ट था सर, शुरू में मतलब स्टील बाहर नहीं आना चाहिए। क्या बात करते हो, नहीं जाएगा और टोको, यस देखो एयर बबल निकल रहा है, एयर बबल निकल रहा है, ये देखो एयर भी निकल रही है ना। पूरा जो क्रैक है, क्रैक विल बी फिल्ड विद इपॉक्सी, लो विस्कोसिटी इपॉक्सी, EP10 है, सीगा2 है, कोई भी आप यूज कर सकते हैं। अब दूसरी साइड में, एक इस साइड में जैसे रफू करते हैं, क्रॉस स्टिच करते हैं, जो इपॉक्सी इसको क्रैक के ऊपर, जो एक्स्ट्रा इपॉक्सी है इसको क्रैक के ऊपर डाल देंगे। टोको जब तक एयर निकलेगी बाहर है तो ये तो काटना पड़ेगा या निकालना पड़ेगा, बस गुड। ये जो इपॉक्सी होता है, इसको क्रैक पर, जो क्रैक डैमेज पोर्शन है उस पर लगा सकते हैं सर, जितना भी आपका क्रैक है इसको क्रैक के ऊपर ऐसे। ठीक है सर, क्लियर हो गया सर आपका ये क्रॉस स्टिचिंग का पॉइंट समझ आ गया सर आपको?
जी सर, थैंक यू।
Anybody last 2 questions? Anybody please? Last 2 questions please.
Sir, this is project Monish.
जी,
What are the permissible limits of bulk density of fly ash for backfilling in RE wall portion? Actually, that slide went a little bit faster. We could not see.
permissible limit of fly ash in RE wall. In RE wall, fly ash as per IRC 10, sir, IRC 102 fly ash is permitted. There are actually 3 soil. Please remember, one is
No,
hill
I'm
soil.
talking about permissible limit, permissible bulk density limits. That's what.
नहीं, फ्लाई एश लिमिट किसके अंदर, कंक्रीट में या सॉइल वाले में सर?
backfilling, bulk density of
एक्चुअली में लिमिट में तो जो रीइंफोर्स सोइल की जगह वी कैन यूज रीइंफोर्स सोइल की जगह वी कैन यूज बॉटम एश, उसमें तो 100
Sir, I am
ओनली इसमें
asking
क्या है
about the
500
bulk
mm fly
density,
ash,
bulk
you
density.
can say
Sir,
50-50,
sir, he is asking.
500 fly ash then 500 earth. Please remember one point, anywhere where you are using non-plastic material, either silt or this, you have to cover minimum good earth 500 mm. जब आप क्लीन ग्रबिंग करते हैं उस सोयल को फेंकना नहीं है, प्लीज रिमेंबर. जो आप क्लीनिंग ग्रबिंग करते हैं, इट इज ए वेरी गुड सोयल, फर्टाइल सोयल. फॉर टर्फिंग वी हैव टू यूज दैट सोयल ओनली. तो जब आप फ्लाई ऐश यूज करते हैं तो जो साइड्स कवर है, यू हैव टू डू विद दिस सोयल सर, गुड अर्थ कवर. फ्लाई ऐश लेयर बाय लेयर करनी है सर. फर्स्ट 500, फिर उसमें परसेंटेज नहीं होगा. कंक्रीट में 2 लिमिट है सर. हाँ, इसमें आप चाहें तो थियोरेटिकली चेंज कर सकते हैं. इफ यू आर यूजिंग 53 ग्रेड सीमेंट, यू आर यूजिंग सिलिका फ्यूम आल्सो, यू कैन इंक्रीज 30-40%. बट उसके लिए कोडल विल नॉट परमिट. यू हैव टू डिस्कस विद द कंसल्टेंट इफ एग्री, थर्ड पार्टी आल्सो. एवरीथिंग इज पॉसिबल. You have to take action, you have to do efforts. Okay, if you are getting a good result, something is not given in the code, we will revise the code next time. Like bonded digital payment, we were not doing earlier. When we get some good results, Gawad or GR Infra, they did some work, some good results we got. Now we prepare the code also. Now it is coming 603 section on bonded digital payment. If you are get like short panel also, we have new code. We have new code on precast concrete payment also. On 17th, we are having a meeting. So after getting some performance better, if suppose something we are doing based on our experience, if suppose somebody is getting a good experience, they should write to IRC. You write to me. At present, I am a consultant to IRC also. So we can bring your matter there and we can give you the reply as per that also. Anything possible not given in the code, please write to the, if it is a better, giving better result. है ना sir? ठीक है.
Sir, what are the codal provisions for the rehabilitation and repairs of the old structures?
Rehabilitation of old structure.
Old structures, yeah.
Building or what?
Structures.
Bridges, sir.
Bridges.
Yes, he is asking about bridges, sir.
Bridges के मैं भी आपको.
Sir, you may kindly place your mail ID in the chat box so that they can send you any questions also in the mail.
I'll just show you. Just 1 minute. Three. अभी खोल दे दूसरी प्रेजेंटेशन. रायपुर में लेक्चर दिया था मेंटेनेंस डे. ठीक है सर. मेंटेनेंस के लिए ब्रिज का 8-10 स्लाइड दिखाता हूँ आपको. फर्स्ट तो ये सर आपका IRC 51 कोड है. देयर आर 2 कोड, IRC SP 37 that is also load testing and IRC 51 that is also load test. What is the difference? IRC 51 is testing of new bridges. IRC SP 37, not 37, IRC SP 37 is load testing of the old bridges to find out the rating. Suppose ये 70R के लिए UDL के लिए, ये 80R 8010 UDL के लिए वो IRC 37 कोड है. इसको टेस्ट करते जो मोस्ट इंपॉर्टेंट पार्ट है. सपोज यू अप्लाई द लाइव लोड प्लस इंपैक्ट लोड, जो भी लोडिंग दी हुई है, लाइव लोड प्लस इंपैक्ट लोड for 24 hours. Suppose it deflects 10 mm. When you remove the load, after 24 hours, you take the reading 7.5 mm, it must cover back. Nowadays, please use total station. आजकल तो रोबोटिक वगैरह भी आ गए हैं. जो टोटल स्टेशन से पहले हम लोग डायल गेज या वो लगाते थे सेंसर, वो बंद हो गया. अब टोटल अभी हमने दिल्ली मेट्रो में किया है, तो हम लोग टोटल सेंसर से आपको डिफ्लेक्शन कवर करना है। प्री स्ट्रेस कंक्रीट 35%, अंडर लोडिंग कंडीशन क्रैक शुड नॉट बी मोर देन 3%। ये हमने कहाँ से लिया? आईएस कोड से लिया। आईएस कोड में भी यही है, देखिए ये आईएस कोड है। आईएस कोड भी वही कहता है। आईएस कोड क्या कहता है? फुल डेड लोड लो, 1.25 टाइम द इम्पोज लोड लो, 24 आवर तक लोड करो, जो रिकवरी है 75% आनी चाहिए। इसमें जो सबसे इंपॉर्टेंट पार्ट कोड क्या कहता है? जो डिफ्लेक्शन है दैट शुड नॉट बी मोर देन 40 एल स्क्वायर अपॉन डी। एल स्पैन हो गया, मान लो मेरा गर्डर 20 मीटर का है, डेप्थ मेरा 1 मीटर है, तो 16 के करीब डिफ्लेक्शन। बिल्डिंग में 20 से ज्यादा डिफ्लेक्शन नहीं होना चाहिए, ब्रिजेस में 16 से ज्यादा डिफ्लेक्शन नहीं होना चाहिए। ठीक है, और ये तो ये ध्यान रखना। अब रिपेयर पे आ जाओ। किसी भी ब्रिज में अगर कोई क्रैक या स्पॉलिंग 30 तक है, देयर इज ए सेक्शन 2800 MORTH 2800 सेक्शन इज ऑन द रिपेयर ऑफ ब्रिजेस, और IRCSP 40 भी है। एनी डैमेज अप टू 30 डोंट वरी, इट इज इन द कवर। जब आप डिजाइन करते हैं, वी टेक फ्रॉम रीइंफोर्समेंट टू रीइंफोर्समेंट, कवर इज ओनली फॉर वाटर प्रूफिंग, है ना। तो अगर कोई क्रैक 30 to 100 डेप्थ तक है, डैमेज एरिया, रीइंफोर्समेंट एक्सपोज हो गया, नो इमीडिएट इफेक्ट स्ट्रक्चरली, डोंट वरी, इट कैन रिड्यूस स्ट्रक्चरल लाइफ। जो 100 ईयर था, हो सकता है वो 70 ईयर चले, बट यू हैव टू वेट एंड वॉच। और सीवियर प्री स्ट्रेसिंग स्टैंड खराब हो गए, रीइंफोर्समेंट स्टील आ गया, फिर आपको क्या करना है? उसके लिए आपको आरसीसी जैकेटिंग दिखा दिया, ये 2804 में दिया हुआ है, जैकेटिंग करो, है ना, या शॉर्ट क्रीट करो IS 901, ये पेज 2803 पेज 76 पर दिया हुआ है, ये आपको ऑलरेडी दिखा दिया। ये हम IRC बिल्डिंग की जैकेटिंग कर रहे हैं। IRC बिल्डिंग में क्या था कि 2 स्टोरी थी, नाउ वी आर मेकिंग 4 स्टोरी। तो हम लोग पियर को जैकेटिंग करके, देखो ये अभी काम चल रहा है, आप चाहे तो कभी देख भी सकते हैं IRC बिल्डिंग का। ये देखिए वीडियो के थ्रू देखिए हो रहा है जैकेटिंग, नीडल वाइब्रेटर से पूरा कंप्लीट कर रहे हैं। अब दूसरा, ये FRP प्लेट पर नया कोड आ गया, IRC 137, 100 गैगा पास्कल, 3400 गैगा, मतलब स्ट्रेंथ इतनी है। कार्बन फाइबर कॉस्ट इज 10,000 रुपीज पर केजी। इसमें थोड़ा सा भी अगर 60% आप फाइबर डाल देंगे और 40% इपॉक्सी होगी, FRP प्लेट से भी आप उसको कवर कर सकते हैं। ये सब FRP, ये कोड की कॉपी है, ये क्रैक के बारे में। इसको ये स्टील हमेशा TMT यूज करना है, माइल्ड स्टील यूज नहीं करना कहीं पर भी। ये एडवांटेज है TMT बार के। ये पुल आउट टेस्ट, ये जैकेटिंग ऑलरेडी आपको दिखा दिया। जितनी आरी वाल है, मोस्टली जितनी आरी वाल फेल हो रही है आजकल, आपको नीलिंग करनी है उसी टाइम। देखो है ना, नीलिंग करके देखो, या नीलिंग करके, ये बनारस के प्रोजेक्ट थे आपको के 10-12 मैंने आरी वाल प्रोजेक्ट देखे। तो जहां जहां पर आपका पेन, तो आपको नीलिंग करके जितनी हाइट उतनी लेंथ का नीलिंग करना है। प्लेट और सेक्शन भी है 2900 मोर्थ में। और कई लोग क्या करते हैं, जो ब्लॉक को कंक्रीट से भर रहे हैं, वो रॉन्ग है। हर 10 मीटर के बाद नीचे होल भी बनाना है, मिनिमम 1 मीटर एम्बेंड होना चाहिए, मिनिमम ग्रेड M35 होना चाहिए। ठीक है, और ये आपका, और ऊपर फ्रिक्शन स्लैब होनी चाहिए। अगर रिटेनिंग वाल है, रिटेनिंग वाल और आरी वाल में क्या फर्क है? रिटेनिंग वाल कंटिन्यूस होती है। Why we have removed retaining wall and converted into RS wall या RE wall reason? The construction of RE wall, reinforced earth wall, is very faster. Less area is required, less time is required, less is the cost. So we are going for RE wall. Retaining wall सबसे अच्छी है, but cost is high. Retaining wall के ऊपर ये फ्रिक्शन स्लैब नहीं डालेंगे। ठीक है, जो आपने फ्लाईएश जो है ना, उस, ये देखिए जहां जहां आरी वाल देखो यहाँ फेल हो रहा है, हम लोग वी आर गोइंग फॉर नेलिंग आल्सो। ठीक है, अब एक रेलवे ब्रिज है ये वेस्ट बंगाल का, वहां पर क्या जैकेटिंग है, ओल्ड ब्रिज था, लाइफ वाज ओवर, तो रेलवे ब्रिज इट वाज डिफिकल्ट टू डिसमेंटल, तो हम लेके उसकी जैकेटिंग कर रहे हैं। देखिए अबटमेंट का जैकेटिंग हो रहा है ब्रिजेस के केस में। एक्सपेंशन ज्वाइंट जब आप बनाएंगे, देखिए पहले डेक स्लैब बनानी है, फिर ज्वाइंट कट करना है, और इसमें जब आप वेल्ड करते हैं, तो जो स्टील प्रोट्यूड होता है उसको ग्राइंड करना जरूरी है, अदरवाइज टायर बस्टिंग होने का चांस होगा सर। बियरिंग की लाइफ, एक्सपेंशन ज्वाइंट की लाइफ, अगर आप इस पर पानी कर रखेंगे 4 घंटे के लिए, एक ड्रॉप पानी भी जमीन के नीचे नहीं गिरना चाहिए। इस पर ये रबड़ सील, जैसे कंप्रेशन ज्वाइंट लगाते हैं ना सर, स्ट्रिप सील, तो स्ट्रिप सील इतनी प्रॉपर होनी चाहिए, एक बूंद पानी भी नहीं जाना चाहिए। और डिब्री एक्सपेलिंग टेस्ट होता है, इसको जब हम 500 बार एक्सपेंशन को ट्रैक्शन करेंगे तो 75% जो एग्रीगेट है वो बाहर निकलना चाहिए, कंप्रेशन टेस्ट वाला। और जो जितना स्टील का काम है, अब उसको डाई टेस्ट से हनी को, जैसे आप कंक्रीट का एनडीटी है ऐसे स्टील का भी एनडीटी है। जितने भी स्टील स्ट्रक्चर है, कहीं भी स्टील जो होता है नेशनल हाईवे में, आपको गैल्वेनाइज यूज करना है, चाहे डब्ल्यू बीम है, चाहे थ्राई बीम है, चाहे मॉडिफाइड थ्राई बीम है, चाहे पोस्ट है, कोई भी स्टील नट बोल्ट कुछ भी यूज करना है, सेफ्टी इक्विपमेंट जो साइनिंग है सारे ऑल शुड बी गैल्वेनाइज। उसको कितनी थिकनेस होनी चाहिए? 85 850 ग्राम पर स्क्वायर मीटर मिनिमम जिंक होना चाहिए उस पर। ये सारे डाई टेस्ट, एयर वायर टेस्ट, क्रैक टेस्ट, ये सब आपको पूरा चेक करना है ना सर।
राइट
जैसे
सर।
देखो बीयरिंग है तो बीयरिंग टेस्ट कर रहे हैं हम लोग पूरे, है ना। इस पर ये सीकाडोर 52 इपॉक्सी है, ये अक्षरधाम की फोटो है सर। इसमें हाईवे बना हुआ है, उसके बाद रिटेनिंग वाल बनाई हमने। NH24 है ये, पार्किंग के लिए स्पेस चाहिए था, 1:2 था, तो हम लोगों ने पहले नेलिंग करी, नेलिंग करने के बाद रिटेनिंग वॉल बना दी। तो ये ब्रिज के हैं सर सारे, ये बोरवेल हो गया, ये देखिए ये तो ऑलरेडी दिखा दिया, थिकनेस गेज है, ये यमुना एक्सप्रेसवे का ही है। कोरोजन क्यों होता है
सर आप
ठीक है सर,
आप
है तो बहुत मेंटेनेंस का। तो इतना और कुछ चाहिए तो आपको भी फिर
सर
दोबारा
आप
नेक्स्ट
आप
लेक्चर
आप
ये
जो
देखिए।
दिखा रहे हो सर, इट इज नेवर गोइंग टू एंड सर, क्योंकि आपने इतना अच्छा सा यहाँ पे ब्रीफिंग दे रहा है, तो मन लगता है कि इसको सेशन को कंटिन्यू करें, बट ड्यू टू कंस्ट्रेंट्स ऑफ द टाइम वी आर नॉट इन अ पोजीशन टू कंटिन्यू सर।
आप दोबारा फिर
लगाएंगे
खाली
सर,
ब्रिज
यस
का
सर।
मेंटेनेंस, ब्रिज का मेंटेनेंस का अलग से रख देंगे फिर।
हाँ, ये
जो
स्पेसिफिक
डिमांड है
इश्यू
उस
के
पर
ऊपर में हम लोग आपके पास आते हैं सर, तो फिर अलग से एक सेशन रखते हैं सर इसके लिए।
कोई
Yes, yes, sir.
दिक्कत
So,
नहीं।
sir, on behalf of NHI consultants and concessionaires, sir, I thank you very much for this wonderful in-depth lecture on quality assurance and quality control, sir. I thank you very much, sir.
थैंक यू सर।
Thank you.
कोई गलत पढ़ा दिया तो ये एक्सक्यूज मी सर।
Not at all, sir. Not at all, sir.
थैंक यू,
Yes, sir.
थैंक यू
Thank you
वेरी
very
मच,
much, sir.
थैंक यू
Thank you.
एवरीवन।
Thank you.